Hola clase. In this video we are going to go through the proof of the product rule, which we've already seen. Remember that when I've got a function that it's a product of two functions, I've got a rule that allows me to derivate. To prove it, remember that I can only start from my derivation by first principles, because that's the only true rule that I've got in derivation. Everything else comes from it. So in this case, f of x would be g of x times k of x. Two functions multiplying, and the reason I put a k here is so we don't use the h that we use in the definition itself. So this substituting into it, same as we start every other proof in derivations. So if I've got f of x, what could f prime of x could look? I start substituting. Limit when h tends to 0 of f of x plus h, so I substitute here, so it would be g x plus h, k x plus h, minus f of x, so minus g of x times k of x, and all of that divided by h, so I just put it here. That's what differentiation by first principle tells me. Now, where do I go from here? Now, if I could only be looking at g of x, I know how to differentiate only that one, just by differentiation by first principles, g of x plus h minus g of x, all of that divided by h. There's not a problem in there. Now, if I've got this and I know it's true, I can cross multiply here until I leave this term alone, g of x plus h. And I would cross multiply, so this h would pass this multiplying, and this term that it's subtracting could pass adding. So I would end it with h g prime of x plus g of x. Now, this is adding here. I can do exactly the same for k prime of h, okay? Which is the second one. Just substituting, I could get to the same thing. Alright, then, if that's true, and they are, I can substitute in here and begin arranging terms. So what would I have? The limit, when h tends to 0, of g of x plus h, but now I just defined it as that, as this arrangement here. So I can substitute here, and I could have h of all of that, g prime of x plus g of x, and all of that could be multiplying the same thing, but for k. K of x plus h would be h k prime of x plus k of x. And that's just a simple substitution, and then I haven't touched here, so minus g of x, k of x, all of that divided by h. Now I've got a multiplication here, so in order for me to see if I can combine like terms, it's just going to expand it, okay? So from here, limit when h tends to 0, and I begin expanding here, okay? h squared g prime of x k prime of x, that's the first term, and then first and second, so plus, I'm just putting the g's first, okay? G prime of a k of x plus second one h g prime, g k prime of x, and then this one g of x, k of x. That's just an expansion. This term I haven't touched, so I'm just copying it here. And of course, all of that divided by h. And now I can begin simplifying. So I've got the same term adding and subtracting, that's going to cancel. And then in every single one of these ones, I'm going to have an h that I can simplify with here, one of them, and that lets me two terms that don't depend on h, one that does. I've got one h here. If h tends to 0, all this term cancels as well because it's multiplied by 0. What am I left with? This term only, and now I can get rid of the limit. There is not an h there. And this term 1 here, adding g of x, prime of h. And all of that was, what were we searching for? The derivative of f of x. Now I've got my proof. Next step, let's put it tidy. And if we want, remember, I can call f of x as g of x, k of x, or if I want to save myself all the writing of the x's, u times b. Then f prime of x is what? Prime of the first times the second plus the first times prime of the second. And that one, I already proved it. I give it a name. It's my product. And as usual, the beauty of math, you don't have to trust me, you can trust the numbers. Thanks for watching.